Okay, we're going to pick up where we left off. Last time we had class, we were switching between polar and rectangular forms of equations. Right here is our toolbox, and we saw this last time, so I won't go into that. So we're just going to practice a few. So I set up two rectangular equations right here, and we are going to switch them to polar form. So these particular examples aren't that bad. I see right here x equals -3, and if I look at my toolbox, x equals r cosine theta. So I'll just replace that x with r cosine theta equals -3. And if possible, I'm going to solve for r. And I can divide both sides by cosine. And I'll have -3 over cosine theta. And if possible, I'm going to go ahead and switch any fractions that involve trig into the reciprocals. So cosine is 1 over secant. So I'm going to be able to switch this to secant theta. This one's going to work similarly. I have y equals r sine theta. So I'll go ahead and switch it over here. And I'll divide both sides by sine. And I'll write its reciprocal. And those two are fairly simple. Keeping our toolbox up, let's go ahead and try one that's a little bit trickier. Now, from earlier in the year, we saw that this would be an ellipse or a circle. In this case, it is a circle. So let's see what happens. I'm going to multiply this out. I could substitute the x and the y right now, but I think it's easier to go ahead and multiply out right here at the beginning. So I'm going to get x squared minus 4x plus 4 after multiplying that out, and the y squared is just right there. And now I'll go ahead and substitute in. So I have r cosine theta squared, because I replaced that x in 4 r cosine theta plus 4. And then I have plus r sine theta squared equals 4. And I'll go ahead and square those. And I'll distribute this 4. And I'll go ahead and square that. Now remember, this squared is actually applying to both these. It's not really distributing, but it does apply to both those items right there. Okay, and this should be squared right here. All right, so if possible, I want to solve for r. So let's see. If I have this 4 right here, I could subtract that over and get a 0. So let's go ahead and clean this up a little bit. That's not a plus, that's a times. All right, now if I were to recall some of our trig identities, we know that sine squared plus cosine squared equals 1. So if I take a look at this, I do have an r squared right there, but I could factor it out. So I'd have r squared times cosine squared plus sine squared. Then I have my 4r cosine theta. And this is all just 1. So I have r squared minus 4r cosine theta equals 0. I'll add this to the other side. Usually I wouldn't do that, but in this case, it actually helps me because now I can divide both sides by r, and I have r equals 4 cosine theta, which is a lot simpler than where we were at a second ago. So a lot of work right there. Take a look at one that's similar. Again, I will multiply out first. And I'll subtract that 9. Just do that right now. And I'll go ahead and put in for x, r cosine theta, and for y, r sine theta. 6r sine theta. And I'll go ahead and square. And I'll square the y as well. And just like before, I'm going to see if I can factor out an r squared here, and I can. And now I have cosine squared plus sine squared, which is simply a 1. So I have r squared plus 6r sine theta equals 0. And I'll subtract that to the other side. So I have r squared equals negative 6r sine theta. And I'll divide both sides by r. I have r equals negative 6 sine theta. And we're done with that one. Only a few more. Let's try, we'll get that one away. Let's try this. Now, I'm going to go from polar to rectangular, and we haven't seen one like this yet. So I'm going to have to use this right here. Now, this is the same as negative 60 degrees. So if you wanted to do it in degrees, that would be fine. It doesn't matter. But in any event, I'm going to go ahead and say that, well, I could put this as inverse tan of y over x, but I'm thinking it might be easier to do tangent of theta equals y over x. So I'm going to do it that way. So I guess I just lied. Oh well. Alright, so now we can tan both sides and we'll get y over x equals the tangent of negative pi over 3. Now, the tangent of negative pi over 3, that would be quadrant number 4, so we're down here. And I believe our tangent is going to be root 3. So, we have y, but it'll be negative, over x equals negative root 3. Multiply both sides by x because we're going to solve for y. And we get negative root 3 x. Not too bad. So sometimes you do have to use this one right here. All right. Let's switch this one to rectangular form. So I'm not going to be able to use this theta one with the tangent because I don't have a tangent. I do have a theta, but it's with a cosine. And this looks like it's awfully close to this one right here. It just needs an r right here. So I'm going to go ahead and get an r right there by multiplying both sides by r. So I'll get r squared equals 4r cosine theta. And now this is simply x. So I have r squared equals 4x. And I do have something I can do with this r squared right here. So that's x squared plus y squared equals 4x. Now this is looking like a conic section. So I'm going to get the 4x to the other side. So I'll have x squared minus 4x plus y squared equals 0 because I subtracted the 4x from both sides. And now I'm going to complete the square. So to complete the square, I have half b squared, which is going to be this. So 4 divided by 2 is 2, and square is 4. So I'll go ahead and add a 4 right there. And if I add a 4 right there, I'm going to have to add it to the other side. And I'll go ahead and factor that. So I'll have x minus 2 squared plus y squared equals 4. So if possible, we want to get a conic section into the work form that we did before, and this would be a circle. This one we might think would work like the last one, but we need to remember that cosecant is the reciprocal of sine. So this one actually works easier than the previous one. This is looking close. I'm going to go ahead and clear my fraction by multiplying by sine. And I'll get r sine theta equals 8. Well, that's just y. So right here, y equals 8. That's just a horizontal line. Pretty simple. But we actually, when we graphed these, we saw that with reciprocal functions that they form straight lines on our polar graph. All right, one more example. Cotangent. So this one is going to be pretty tricky. So just to play around with some ideas, I could write this as cosine over sine, get equals -5. And then if I cleared my fraction, I get -5 sine theta. But that's not like any of these. But if I multiplied both sides by an r, well, now I have x equals -5y, and I could solve this by dividing by -5. So y equals -1/5 x. I was going to play around with maybe if I switched it to 1 over tangent, could I use this somehow? So I could multiply both sides by tangent, and then divide by -5. And we know using this that tangent is going to equal y over x, tangent of our angle. So, and now I multiply both sides by x, and we get the same answer. So multiple ways to get the same thing on that one. All right, that wraps up switching to and from polar and rectangular forms of equations.